In order to tap the full potential of the Internet of Everything, zero trust has to be imposed at each and every connection firing off within hyper-interconnected environments. I spoke to Steve Hanna, distinguished engineer at Infineon Technologies, all about how this paradigm shift is unfolding.
So that whole concept of a perimeter, and you keep the bad guys out and the good guys have to stay inside the castle, doesn't work anymore. Most IT departments have moved to a more flexible model, which is called zero trust architecture. Now that zero trust architecture is getting adopted even beyond IT departments and laptops, desktop servers, and that sort of thing. As we all move to the Internet of Things, we're adopting that same zero trust architecture for the IoT also.
Give us a little bit more on zero trust, the general term, how it came about, and then the architecture piece of it.
Well, the general term and the general principle is really just one very simple one, which is nothing should be blindly trusted. Everything needs to be verified. First of all, you can't just trust the network and assume that everybody on the network is secure and safe and good. So you have to secure all the communications, whatever your network you're on, Wi-Fi or Bluetooth or whatever, it needs to be secured, even Ethernet. Second of all, everybody needs to be authenticated. All the users need to be authenticated. All the devices in an IoT world need to be authenticated, and also the cloud services, so that everybody knows who they're talking to. And third, we are not just going to give total power to any one party. Every request for access has to be authorized. So there has to be rules about who can do what, when, how, where, all those sorts of things. The fourth principle is that everything needs to be monitored, especially from a security standpoint. So what we're really working towards here is a system where your Internet of Things in your home or in your smart city or your smart factory has all these security mechanisms built in from the start, and then the end user doesn't have to worry about it.
Help us understand how huge a challenge this has become and how it's even a growing challenge, because now you're talking about hyper interconnectivity to make these Internet of Things systems deliver services.
So this is exactly why we need this zero trust architecture, because there's so many moving parts in a modern smart home or any other IoT environment. Any one of those parts, the light switch, the light, the cloud, the app, the development environment, could be the source of an infection. And that's why all of these things have to work together using open standards like Matter in order to secure the whole system.
So the notion of architecture, instead of a castle wall, you're going to take a design approach that allows detection, response, monitoring, assurance to happen in real time, all the time, in this fantastically complex and dynamic environment.
The devices can go wherever they need to go. The users can go wherever they need to go. If you need to take your mobile phone on the road and control and monitor things inside your house, you can go and do that. Mm-hmm. And it's still going to be secure because the network is not part of the architecture in terms of trust. The mm-hmm. network is not trusted. The communications is secured between your mobile phone or any other controller and the device. So we're really empowering the consumer to put their IoT devices wherever they want, hook them up in any way that they want, and all of those devices are going to know which other devices they should trust. Mm-hmm. So it's a much more flexible, much more powerful, and ultimately much more secure architecture than the old perimeter model.
So we can do this now. We can do zero trust architecture because of advances generally in computing and network capabilities.
Yes. So we now have these networks that are used in IoT, things like Thread and Wi-Fi, that are capable of carrying the communications between the devices with a little bit extra room. There's a little bit extra battery power in the device that allows for a slightly longer message so that it can include that encryption and authentication. The low power processors, such as the Infineon PSoC line, PSoC 4, PSoC 6, and PSoC Edge, are microcontrollers units, include built-in cryptographic accelerators that make encryption and authentication really fast, power efficient, and easy to implement. And so instead of the old days when we had to communicate using unencrypted and unauthenticated communications protocols, now all of those communications protocols can be secured without costing too much in terms of power, in terms of budget, in terms of board area, anything like that.
So, the last 24 years, we went from perimeter out to the wide open edge at the outer boundaries of the internet, where all these connections are taking place. And in a sense, security now has lagged, but is going that direction as well, out to the devices. Is that one way to think about it?
Yeah, exactly. We're breaking down those walls that had previously been built in the IoT. There's the concept that you had to have a protected network and you could only use IoT inside there. We're breaking that down through these more powerful, more capable, more secure MCUs and better communications protocols with more bandwidth. We're now able to let these things communicate securely, wherever they are.
And the notion of zero trust architecture, where are we in that trajectory? I imagine we're early.
Well, things don't change overnight in the world of IoT. Many, I guess I would say most of the devices, IoT devices on the market today, do not yet have support for zero trust architecture. But as more and more of them adopt more modern standards like Matter, these security features and the zero trust architecture approach come along with it and give greater flexibility, greater interoperability, and stronger security. And it's none too soon, I guess I would say.
I wonder if we could talk about the expanding attack surface. That's the flip side of all this great innovation. It continues to expand. Could you set the scene for us? How much of a pressure is attack surface growth adding to the situation?
It's really tremendous, Byron. As we see more and more things becoming smart and connected, those things are therefore open to attack because any smart connected thing can potentially be attacked. In a few years from now, it seems that everything that has power will have smarts and connectivity. It enables all sorts of wonderful use cases. But with that new power comes new vulnerability because the attackers now can come and attack all of those things.
The notion of having many layers of security isn't going to go away. But what we're talking about here is IoT devices at the edge, embedded in the hardware, in the microchips, is this capability.
That's true. That's very astute, Byron. So traditionally, IoT devices at the edge had very limited capabilities, and they wouldn't have the ability to have a unique identity. Now, our IoT devices are more capable. They have secure storage locations for things like a certificate and a private key. And they have the cryptographic acceleration hardware that we have in Infineon's PSoC processors to enable them to perform the asymmetric cryptography, the public-private key cryptography that's necessary in order to prove that unique identity and to check the unique identity of whoever else they're communicating with.
Back to the original point here, and having the ability to implement zero trust architecture.
That's right. You can't implement zero trust architecture if you can't authenticate uniquely each user's service or device. So we had to have that capability within each IoT device in order to implement zero trust architecture in an IoT setting.
What I'm wondering is, with zero trust architecture and the path we're on, is that path robust enough to meet the challenges that we don't know of yet that will come from wider implementation of Gen AI in commercial settings, post-quantum computing, and whatever's beyond that, right?
So zero trust architecture itself has a lot of good capabilities that allow it to recover from any attack, whatever the nature of that attack is. So with zero trust architecture, every device and every component in your IoT system is mutually a little distrustful. They're going to authenticate each other. There's going to be that monitoring we talked about, looking for suspicious behavior. And then if they detect, well, wait a second, why is the refrigerator trying to control the front door? That doesn't make sense. Then there can be a response to that to say, I think this fridge is infected and we're going to quarantine it and we're not going to let it control anybody else in the house. Maybe alert the user to it as well. That's how zero trust architecture can help to address threats that we haven't even thought of and problems that we haven't even considered.
Have you noticed that as zero trust architecture implementation ramps up, are we seeing unique vulnerabilities, things you didn't expect?
Yes, I think one of the things that we're realizing now is that building secure systems, it's really a team sport. There's a role to be played by the standards groups and the cryptographers and the chip makers. Also, the designer of the IoT system has to use secure development processes when they are building their software that runs on top of the Infineon processors and communications chips, even in the case where the firmware gets exploited. And then that device can heal, it can be rebooted, it can get that over-the-air update and then verify it and install it and update the firmware on the device. That's where we want to get to, devices which are capable of healing themselves. But there is a shared responsibility there, not just on the hardware maker, the chip maker like Infineon, but also on the device maker as well.
Well, that's fascinating. So this whole notion of not just infinite passwords, but passwords plus this architecture supports updates and resiliency in the sense of self-healing.
Yes, that's one of the great things about the zero trust architecture is that it's designed to be extensible. So, I mentioned earlier that one of the principles of zero trust architecture is that the security of the devices, the networks, the users, and the software is monitored over time. And then that they can be a quick response when a problem is detected. That capability, that monitoring and response capability, is today in most smart homes very simple. But over time, I expect that AI and machine learning will enable us to have more automated and artificially intelligent monitoring of traffic within the home. That's something that you typically only see today in a corporate setting. But with AI and edge computing, I expect to see those levels of intelligence and automated response coming down into the home and getting incorporated into the smart home in years to come.
How much of a factor is boosting efficiency? Can this help that as well?
Yes, one of the most painful things when building an IoT system is debugging it. When there's a problem, it can be very hard to figure out what caused that problem. And I know we all want to build reliable and secure systems. The best way to do that is to build in cybersecurity from the start using an approach like zero trust architecture that is well designed and well architected for the future.
Well, we've covered a lot of ground here, Steve, and I've, as usual, learned quite a bit.
Well, Byron, it's always a pleasure to talk to you. You have such great questions and really gets me thinking about it as well. So thank you again, and I look forward to talking to you in the future.